Ladies and gentlemen, welcome to the 2025 COMPUTEX Forum organized by the Taiwan External Trade Development Council, TAITRA. I'm your MC for today. My name is Jenny Chang. To begin the forum, let us invite the organizer of the COMPUTEX Forum, Mr. Simon Wang, President and CEO of TAITRA, to deliver the opening remarks. Ladies and gentlemen, please give a warm welcome to Simon.
Hi, everyone. Good morning. As the organizer of COMPUTEX, it's truly a great pleasure and honor for me to welcome you all to join us at this gathering of visionaries and innovators. Taiwan has long been at the heart of the global ICT industry. I often recall the story of how, some decades ago, a handful of determined engineers in Hsinchu transformed a small island into a powerhouse of semiconductor and smart technologies. Today, Taiwan continues to connect the world, not just through chips and circuits, but through shared vision, collaboration, and relentless innovation. And this year, as we explore robotics and edge AI, generative AI, and data center solutions, we are proud to host trailblazers from NVIDIA, Google, DeepMind, Texas Instruments, Advantech, and many more. Together, we're not just shaping technologies, we are building the future. Let's spark ideas, forge partnerships, and accelerate breakthroughs. Welcome to COMPUTEX Forum 2025, where we together power global innovation. Thank you.
Thank you, Simon, for the warm and inspiring introduction. Now, let's begin our innovation journey by welcoming the first speaker of the COMPUTEX Forum, Mr. Deepu Talla, Vice President of AI and Robotics at NVIDIA. His topic is Physical AI and Robotics, the next multi-trillion AI opportunity. Ladies and gentlemen, please welcome Mr. Talla to the stage.
Good morning. 2025 is such an exciting year for me personally, because I've been working in the area of robotics and edge computing for more than 10 years. And I always felt like I was in the future. This is the first year I feel the future is coming to the present. So we're going to share, the presentation is going to be roughly in two parts. First, I'm going to talk to you about why now, why I'm so excited about 2025, and show you some of the technologies that NVIDIA and our ecosystem is enabling. And then the second half, I'm going to show you real deployments, real work being done using all of these technologies in Taiwan to apply AI to the physical world, manufacturing facilities, warehouses, and so on. So let's get started. First of all, I want to thank you to all the Taiwan partners. We have over 350 companies in Taiwan that are helping NVIDIA build our data center and our AI factory infrastructure. And given that all of those companies are physical companies building real physical goods, everybody is embracing robotics already. If they're not, they're already, the journey has begun. So thank you to all the partners here in Taiwan. So did most of you watch Jensen's keynote on Monday? Anybody did not watch? Okay, everybody watched the keynote. So it's my job is super easy now. And guess what? If you don't understand anything I say, which is highly likely, I have a video from Jensen which will clean up every mistake I'm going to make in this presentation. So in all cases, you're covered. So you've seen NVIDIA journey in the last, last 20 years or so in the area of computing, starting with chip with CUDA in 2006, and then we had the DGX1 system in 2016, the first one going to OpenAI, and then 3-4 years ago, we started building data centers, and now we are in the point of making AI factories, which are going to generate tokens, and tokens is essentially a factory generates tokens, and factory generates revenue. So the more tokens you generate, the more revenue you generate. So we have been on this mission, and in the last 3 to 5 years, you've seen it's not even it's not even an exponential function. Sometimes I feel like step function progress is being made. So you've seen this slide as well. What started with deep learning 10 years ago? What started with deep learning 10 years ago? Sorry, I'm distracted by somebody changing the slides there. Please don't do that, whoever you are. I got to see which slide I'm presenting, sorry, so I have to come over here. Okay, so what started 10 years ago with deep learning, right? We applied it for perception problems with computer vision. And then we've seen generative AI with transformers happen, call it since 2020 or so. And then 2022, the ChatGPT moment happened and suddenly it took off. We are in the agentic AI world. And now we can apply the same large language models, apply it to vision, apply it to action, which means we can apply that technology to the physical world. We are in the era of physical AI. And in fact, why we need to solve this physical AI, the reasons are very obvious. It's not new information. I mean, labor shortages have been going on for a good, labor shortage has been going on for a good 10 plus years, right? And in fact, the world is also changing where manufacturing, supply chains are getting continuously changed now. There is reshoring happening. In fact, it's said that in the next 3 to 4 years, $5 trillion worth of factories, warehouses, manufacturing are going to be built because of this trend of reshoring. So that need has existed. Of course, it's becoming more and more important. That need is becoming greater and greater. It's not that we didn't try as an industry to tackle that need. For 10 years, in the last 10 years with deep learning and AI, we of course have been trying to use that AI technologies and put it into physical AI problems, robotics problems, whether it is for autonomous navigation, whether it is for manipulation, pick and place, or even general purpose AI in the future. We've been trying to do all of this. And the best in the world have tried it, but the technology has not really caught up. Whatever solutions we came up with has been brittle. But something changed in the last 12 months. This is what brings us to 2025. The ChatGPT moment of robotics, physical AI has arrived. So two fundamental technologies have reached a tipping point. They have reached a reasonable, good enough maturity that we are able to, at scale, start developing and testing them now. Number one, of course, you're all familiar with physical AI, meaning large language models, vision language models, action models. So the whole, given that this industry is by far the largest opportunity that we have, it is not surprising that when technology has matured, that the best in the world are now starting to work on this technology to bring AI, not just ChatGPT in the digital world, but bring equivalent technologies to the physical world. So that's one. Number two, we've been working on simulation for over 15 years inside NVIDIA for physics type of problems. With NVIDIA Omniverse, it's the operating system for a digital twin. And finally, we have reached a tipping point with that technology also. It is reasonably mature now, sufficiently mature that we can solve real-world problems. It is Omniverse now is integrated to many different industry tools. We can do simulations for physics modeling. So when we combine both of these technologies, we are at that tipping point. And that's why I personally believe the future has come to the present finally. The opportunity itself is extremely large, right? The world is, call it $100 trillion, and much of it is in the physical world. ChatGPT and Copilot and all the technologies that we use, of course, fantastic productivity improvement for us as an enterprise or a software developer, or compose an email or summarize a document and so on and so forth. It's fantastic. But now we are able to, if we can take that technology and now put it into physical world, we've got millions, 10 million factories, hundreds of thousands of warehouses, and the future, quite possibly the largest opportunity for humanity, humanoid robots, where there's a potential that every human will have more than one robot, cute R2D2s, maybe a pet, maybe a companion, maybe household chores. There's going to be many of these that's possible in the future. So this opportunity is so big. The great news about this is because of these two technologies maturing, the best in the world now are coming into this industry. You take a look at how many startups are being funded, whether it's for humanoids or whether it's for building robot foundation models or world foundation models. You hear about all of these terms that's happening in all over the world in research and in startups because of this opportunity. This opportunity always has been the biggest, but technology was not available until now. We have two pieces of technology that are essential that have matured. So what do we do at NVIDIA? So we are a platform computing company. We provide technology. We do not build robots, but we provide technology. And then we work with the whole ecosystem that are building their platform or their solution. And we embed our technology into ecosystem partners' platform or solution. So the problem is three things that we need to do. If you want to build a robot, if you want to build anything, there's 3 steps, right? Step 1, you design and build it. Step 2, you have to test it. Step 3, you deploy it. And then in the case of these robots or machines, or the job is not done once you deploy it, right? That's just still in the early stage of the journey, because these are going to be in the factory or warehouse or home or hospital or wherever you deploy it. They're going to be operating for the next 5, 10, 15, maybe even 20 years. And they're going to become more and more intelligent. These are software defined. So this loop of build, test, deploy is a continuous journey. So we built 3 computers for those. 1 computer to build the AI, to train the AI. And this has happened typically in AI factories. If you saw Jensen's keynote, which most of you have, you see these AI factories. GB200, NVL72, the latest version that's available. And many of them are being displayed here by our partners in the COMPUTEX show floor. So you train your model. Once you train your model, you have to test your model. In fact, it turns out the worst way to test your model is in the real world, because it's the slowest way to do it, it's the most expensive way to do it, and it's the least safe way to do it. But until recently, we had no choice. If you're a chip designer, I'm sure some of you are chip designers here, we never tape out a chip until you simulate, emulate everything. And then when you're sure, that's when you send it to TSMC, for example, right? To the fab. Because otherwise, if you tape out without fully testing in simulation, emulation, it's so expensive to tape it out to TSMC. The mass cost and the time it takes, the same thing is true for robotics. But then why do you say, why could we not do it in simulation before? The technology was not good enough. We had this so-called sim to real gap. And now that gap is significantly reducing. So because of NVIDIA Omniverse platform we've been working on for over 15 years, matured. So the second step is test it in simulation. Once you test it in simulation, you deploy on the runtime computer, which is the brain of the robot. And this loop continues. So what we do at NVIDIA, we provide the infrastructure for all the 3 computers. And then we provide acceleration libraries, software tools, and workflows and reference models. And all of this technology is available openly to everybody. And then we work with all the robotics companies, all the AI companies in the world to take whichever parts of our platform make sense for them. It is not an all or nothing. Whichever part makes sense, We will help you integrate into your platform, into your solution, and we'll help you take it to market. So that's what NVIDIA does in this area. Provide the infrastructure for the 3 computers and the associated software libraries and software stack and reference workflows. Okay. However, there's one problem. Step 1, 2, 3 sound good. Design, test and simulation, deploy. That sounds logical. But it turns out there's a step 0 that's required. In the case of ChatGPT, we had the whole internet, right? All the books, all the libraries, every text that humanity ever created for centuries and maybe even thousands of years is all available somewhere. And the AI could be trained on that data. But in the case of robotics, where is the data? It turns out there's not really data. Now, you could argue that I can do imitation learning and show the robot. Okay, you can do somewhat. You can say, I'm going to put a motion capture suit and capture me. That's fine, that's some. Or you can put a Apple Vision Pro. You can do teleoperation and demonstrate. That's fine. But it turns out all of the data is going to be a fraction of 1% of what you need in order to create a good foundation model for robotics. Remember, in the physical world, the accuracy is not going from 75 to 80%. It's 99 point, how many nines do you need? In the case of AV, maybe it's 10 nines. In the case of certain applications, it's more than that. In the case of, but it is almost always 99.1, 2, 3, 4 nines. So that level of accuracy requires supremely high quality data. So that we have a data problem. Now you can say, okay, guess what? We have YouTube and TikTok, and in the last 5 years, there's so many people put so much data. Why don't we use that to train the robot? Get a dancing robot, maybe, but it's highly unlikely you're going to get a robot that's going to be useful in the physical world, doing real physical tasks at good accuracy. So that's the problem. So that's the problem that technology, fortunately, is now available for us to solve the data problem. And well, the answer is not the real world data. Real world data is necessary, of course, but not sufficient, right? So synthetic data generation. Synthetic data generation is not a new concept again. Why couldn't we have created synthetic data generation 3 years ago and just did it? But the problem is technology wasn't good enough. So we started first with NVIDIA Omniverse, creating 3D models, sometimes artists, to create 3D models that are physically grounded and accurate. Remember, we're talking about robots, physical world, accuracy is extremely important. So unlike movies or videos or pictures where we can make it look good, but physics is not as important, photorealism is more important, but physics is maybe not as important, robotics requires extreme physically accurate, right? So we use Omniverse to create synthetic data from 3D. But still that is not enough. So what do we need to do? So what we did, we can use generative AI. So in fact, we announced this product called NVIDIA Cosmos earlier this year. You can use generative AI to prompt, whether from text, whether from speech, or give an image, or even a video, and say, generate me more video. And that's possible now because of generative AI. So we can generate more synthetic data using generative AI. When you combine physically accurate data from Omniverse, and then you add generative AI on top and ground it, now we are able to generate large amounts of physical world, physically accurate data. Now this technology is super important, step 0. So once we are creating this data pipeline, in fact, you see the number of companies working in this area, step 0 to create the right data so that you can go to step 1 and train the model, step 2, simulate, step 3, deploy, right? So step 0 is super important, and we have been spending a lot of time. Our platform and some of the best in the world are now spending a lot of time on creating this data. Okay, so now let me show you, summarize all of this for you. And as I said, if you didn't get what I said, we have our CEO Jensen, helped create this video with all the partners in Taiwan, and let's see how they are, using.
Taiwan is pioneering software-defined manufacturing. TSMC, Foxconn, Wistron, Pegatron, Delta Electronics, Quanta, WeWin, and Gigabyte are developing digital twins on NVIDIA Omniverse for every step of the manufacturing process. TSMC with MedAI generate 3D layouts of an entire fab from 2D CAD and develop AI tools on COOPT that can simulate and optimize intricate piping systems across multiple floors, saving months of time. Quanta, Wistron, and Pegatron plan new facilities and production lines virtually prior to physical construction, saving millions in costs by reducing downtime. Pegatron simulates solder paste dispensing, reducing production defects. Quanta uses Siemens Teamcenter X with Omniverse to analyze and plan multi-step processes. Foxconn, Wistron, and Quanta simulate power and cooling efficiency of test data centers with Cadence Reality Digital Twin. And to develop physical AI-enabled robots, each company uses its digital twin as a robot gym to develop, train, test, and simulate robots. Whether manipulators, AMRs, humanoids, or vision AI agents as they perform their tasks, or work together as a diverse fleet. And when connected to the physical twin with IoT, each digital twin becomes a real-time interactive dashboard. Pegatron uses NVIDIA Metropolis to build AI agents who help employees learn complex techniques. Taiwan is even bringing digital twins to its cities. LinkerVision and the city of Kaohsiung use a digital twin to simulate the effects of unpredictable scenarios and build agents that monitor city camera streams, delivering instant alerts to first responders. The age of industrial AI is here, pioneered by the technology leaders of Taiwan, powered by Omniverse.
Thank you. So it is super cool. I've been coming to Taiwan for 20 years in different jobs. I was doing digital cameras first, and then smartphones, and now robotics. Last year was the first time I felt like there's a significant change made in Taiwan, where Taiwan's not just about hardware and software experts are in Taiwan. And just in 1 year, you see all these deployments happening. Just shows the amount of progress, and it's fantastic to see. So thank you again to all the Taiwan partners. So that was the technology, and I explained what we do at NVIDIA and all the technology pieces of technology that we bring to the market, and then we integrate this technology into our ecosystem partners. Now let me switch gears and show you examples of how our partners in Taiwan are leveraging this technology to solve some of these physical AI problems. So if you think about AI to solve these physical problems, you need two types of systems. One, what you can call an inside-out system. Just like humans, like a robot, has sensors, right? Eyes, mouth, ears, and other senses. We perceive the world inside out. However, there's also another component, which is called outside in. If you take a warehouse or a factory, there could be cameras and other sensors that are watching things that move. So if you can fuse inside out and outside in, you will get much greater intelligence, and you can solve problems. It's similar to pilots and planes. They fly autonomously, but there's air traffic control, right? Watching all the different planes that are, which each plane cannot see. So we are building technologies for both inside out and outside in, which are both are important to solve physical AI problems. So let's jump into the first examples of companies that are doing inside out. In fact, it all starts with a digital twin. Remember I mentioned testing and simulation? The fastest way to solve this problem is to test in simulation. The slowest way to solve the problem is to directly deploy on the physical world, which we have been trying to do for decades, and we can't move fast enough. So every company's journey starts with a digital twin using NVIDIA Omniverse. Now, you could argue, do I need a full fidelity photoreal simulations from day one? Maybe not day one, but it is very important to start working on a digital twin, bring all the different 3D into it, and then making it photoreal will become more and more important, because imagine 10 years from now, okay? A factory is fully autonomous. It will have many types of robots, AMRs, industrial arms, cobot arms, humanoids, humans, all of them are orchestrated. How do you orchestrate such a system in the real world? You can try all the experiments in the real world because how do you know how the AMR is going to behave? How do you know how the humanoid is going to behave between humans? You can't test it in the real world. You have to test it in simulation. So the journey always starts with a digital twin first. So let's look at some of the companies that are in Taiwan doing it. So I'm going to go through a few examples real quick. So we have our partner Advantech, who is developing AMR for smart hospitals, and done first in simulation. Because what are the chances that you can actually develop this robot in the physical world and test it first time in a hospital? No hospital will let you do that. So you have to do it in simulation, right? Makes sense. Delta, AMRs, super important to move goods from point A to point B with all these changing needs nowadays. You can't pre-program these robots. You want them to be more and more autonomous. They're using simulation. Again, simulation, simply three things: faster, safer, cheaper. Foxconn, especially for greenfield facilities, you can actually put these, you can do a digital twin simulation of the greenfield facility, which will actually allow you to do all the layout of the factory and optimize it before you commit real money to build a physical one. So it saves significant amount of time. So it's 50% planning time. That's huge. If you're building a factory, if it takes 1 year versus 6 months, that's huge. FoxLink, another example, building industrialized robots for operating in not safe for human environments like an earthquake or a flood or a fire. A lot of these robots are now starting to get deployed. Gigabyte, production layout optimization. Again, starting with a journey starts with a digital twin. Quanta, same idea. How many robots do you need, and what's the throughput going to look like from point A to point B across the whole factory line? Test it in simulation first. Test the robot policy in simulation. If you like the answer, then go and deploy in the real world. Solomon, they are doing excellent manipulation. And manipulation is an extremely challenging task because, for humans, it's so easy. I mean, if you see a bottle of water, we know what to do. But for a robot, it's avoiding obstacles, determining what the pose of the object is, determining what the physics of it is, how much pressure you need to put, what's the trajectory of the motion of your arm to go around it. All of these needs to be constantly be evaluated. And we are now have the technology, the AI technology for trajectory planning, for motion planning, for pose estimation, for depth estimation, all of this, combining all of this together, we can actually solve this manipulation problem for gripping manipulation. And guess what? What are the chances you can do this in the physical world right away? It makes no sense because you can only test 1 or 2 robots. But in simulation, we can test hundreds of robots in parallel. So Solomon is doing that for visual inspection. TechMan robots, they're also demonstrating here at COMPUTEX, similar idea, doing it in simulation. TSMC, you saw it in the video, the new fabs that are being built. It's the whole of new fabs and new manufacturing is being done in digital twin. Wistron, same idea. So you can see pretty much every company in Taiwan. Of course, Taiwan is the land of physical things. So obviously, the perfect place to test all of these things. Weavin, same idea, developing some of these products using simulation. Okay. So those are examples of the first part, inside-out perception. Now let's switch gears, in the 3 minutes that I have. Outside in. Outside in is like air traffic control. If you can leverage all the cameras in a city or a building or a warehouse and process them spatio-temporally, right, in space and time, fusing all those, you can get real situational awareness. Because, for example, I don't know what's behind that curtain, but if an air traffic controller tells me if there's a danger there, I'm not going to go in that direction, right? So we can fuse that. So we've done, we have technologies for what we call Metropolis. That's the platform for outside-in perception used throughout the world. We've been doing Metropolis for the platform for more than 10 years. 1,000+ software companies have embraced Metropolis for all sorts of applications, for smart cities, to factories, to safety applications, to traffic, to optical inspection. So we released a new blueprint that leverages the power of large language models, vision language models, retrieval augmented systems, right, our RAGs, and we've created blueprints that enables you to really just, for a factory operator or a manufacturing operator or a city operator, you can just ask queries and questions. You don't need to be an expert at AI. So for Metropolis, you saw the example in the video, Pegatron, factory assembly, all the steps in the right order. Just use vision language models to make sure that the steps are right. If it's not, it flags an error. So it's much more easy. This technology did not exist just a year or two ago. So that's what's super exciting right now between the AI technology, the physical AI technology, and simulations, what's enabling us to do all of this in a rapid manner. Let's say TSMC, they are using transformers and vision language models to increase the defect inspection, which was handcrafted algorithms. It's beating the accuracy of those. And then last but not the least, you also already saw Linker Vision in Kaohsiung, where they're building a digital twin of the city and using the power of video to solve a lot of city scale problems. So to summarize, I've showed you the technology building blocks that we have at NVIDIA, and we deliver that technology in an open platform manner to every company working on robotics or AI, and we help you integrate parts of our platform into your platform or solution. And the journey for physical AI must always start with a digital twin. That is the fastest, safest, cheapest way to get there. Any other way is not a good answer. Okay? So once you have a digital twin, you can do lots of experiments. Outside in is easy to start with because the infrastructure already exists, cameras already exist, so we can use AI. And then you can, if you're building a humanoid robot, if you're building a AMR, you can continually use this journey. Okay, and then lastly, to mention, as I said, we don't build robots. We are a platform company, so we work with literally every robotics company, every ecosystem partner across all layers of the stack, from hardware to software to simulation to system integrators across the board. Okay, so hope it makes sense. I think this is the year where we brought the future to the present. Happy roboting, happy physical AI development. Thank you.
Thank you, Mr. Tala, for your inspiring presentation on physical AI and robotics. Now, let's move on to our next speaker, Mr. Ed Chi, Vice President of Research at Google DeepMind, to demonstrate how Google Gemini helped bring AI to the physical world. Ladies and gentlemen, please join me in welcoming Mr. Chi to the stage.
All right, it's always a pleasure to be back in Taiwan. I 土生土长的台湾人, so always very, very happy to be back. Thank you so much, appreciate it. So every year I come back, it's always because of some sort of event like this. And last night, I don't know how many of you slept well last night, by the way? Any of you slept well? So I see probably only 10 or 20%. So maybe for those of you who didn't sleep well, you actually pay some attention to what happened yesterday, or at least what we think of as being yesterday. But yesterday, obviously, we have a very big event at Google, and that was Google I/O. And the big theme today was bringing research to reality. And so today I'm going to talk about all the research that we're doing that's leading into this generative AI revolution. We announced a bunch of different things that Google has been working on, and there are many, many details in there. So I encourage you to go on YouTube to listen to the keynote and learn about all the different innovations that are happening right now. But I wanted to highlight a couple of different things today for you to understand a little bit about what's going on. The first thing is that Google is right now shipping at a relentless pace. It's quite amazing if you think about merely a year ago, right? From this past year, the amount of innovation that has been happening across the company, that we have been leading in the industry. So it's not just because of the velocity that we're doing, but also because of the scale that we're doing this at. If you think about what has happened in the last year, for example, merely a year ago, we were serving 9.7 trillion tokens monthly. And today, we are now serving 480 trillion tokens in a single month. A growth of 50x in terms of the scale that we're actually delivering generative AI to everyone. It's not just the scale, and it's not just the velocity, but also the quality of these models have improved very, very dramatically. Now, my team at Google DeepMind actually participated in a lot of these quality developments. So going from merely a year ago, when our ELO points on LM Arena was just a little bit over 1,000, we're now approaching 1,500, an improvement of nearly 50%. And it's not just velocity, it's not just scale, it's not just quality, but what we're doing is also ensuring that our model is the best across the entire industry. #1 in every category. Thank you, thank you. Our Google colleagues are very excited about this, obviously. And I am too. The amazing thing is about the quality improvement, the scale that we're able to deliver to our customers means that we can bring generative AI to more people than any company in the whole world. And Google Search is, in fact, leading this revolution to help us deliver this technology to all of you. For those of you who are Google users, I hope we can count on the support of all of you. At this point, AI Overview is actually serving more than 1.5 billion users every month. Right? So we're bringing this technology directly to the consumer in a very visible way. And Sundar also announced yesterday that AI mode is becoming more available across the surface as well. So I encourage you to please try that out and let us know about your feedback so that we can improve on this technology and bring it into your hands. Now, that's all just about all the hype that was happening yesterday that we're bringing to you, the consumer. But I'm a scientist, right? And as a scientist, what I really want to make sure every time I get a chance in front of a large audience like this is for you to really understand all this jargon, what's going on, scale and quality. What's generative AI? It's interesting because every time I come back to Taiwan, I read the major newspapers, and they all talk about generative AI. But I ask my friends, do you even know what generative AI means? How is it different from the previous AI that we have? And they don't understand this. So I wanted to take just a few moments to set the stage for the rest of the talk so that you understand a little bit about what's going on in this revolution. Why the researchers, we consider this to be a revolution. So in 2015, we already knew from a neural network perspective that there are various different functions that we can get the neural network to learn. Now, I don't know how many of you remember this, but in 2010, 2011 or so, this task where we give a computer an image of something, let's say if I had taken a photo right now and ask it, what do you see? It turns out the error rate was 26%. And by 2015, because of some of the work that was going on in neural networks, this error rate had dropped to 3%. Okay. Almost an improvement of 10x. Many of you may remember, I see an audience member in front of me holding up a camera. You may remember taking a picture and getting the machine to understand what's in the picture was very, very difficult. You know what else was very difficult? Audio recognition. I don't know how many of you remember the mobile phone revolution that happened in 2007. And by 2010, you were supposed to be able to pick up your phone and say, call mom. By the way, my mom is in the audience today, right? So, and you say call mom, and it doesn't call mom, right? It calls somebody else. And the reason was because that error rate was still so high. But in 2015, we were able to answer queries like, how cold is it outside? By these neural networks. What else was happening? Yesterday, Sundar announced that live translation is coming to Google Meet, for example. How is that technology built? You say, hello, how are you? And instantaneously, not only does it translate in French, bonjour, comment allez-vous, but actually sounds it out. And you can even sound it out in a very natural sounding voice. How is that even possible in the technology that we were looking at before? And then finally, in 2015, this was the one function that really blew my mind. It was that you give the machine a picture and you say, please describe it. And it says blue and yellow train traveling down the tracks. Now, I don't know all of you, but if you knew in 2015 that the generative AI revolution was about to happen, I think you would have all bought your stock in a very different way. Do you agree? You might have invested in lots of different companies that were already participating in the generative AI revolution. So if you had that foresight, if you knew what researchers knew in 2015, how incredible this technology was, think about it. The fact that in English, we tend to say blue and yellow and not yellow and blue. Why? Just like a convention, CMYK means that we tend to say blue before yellow. RGB, we tend to say red before green because of this ordering of the colors. So the machinery, the natural language model knows about these language conventions. It spells traveling with two L's. It knows it's tracks and not track. By the way, a very common mistake by Mandarin speakers of English is forgetting to parallelize. And our machinery can do all this. But you know what you all missed, if you had the foresight in 2015, is that two of these functions are very, very different from the other two. Why? Because hello, how are you? Each token is fed into the model one at a time. And then the output, bonjour, comment allez-vous, is also output from the model one token at a time. The fact that it's output one token at a time, that's why it's called generative AI. So 2015 was literally the beginning of the generative AI revolution, and a lot of us missed it. A lot of us missed this. Why did we miss it? That's a very interesting question. But what it enabled was that all the function I just showed you is that we can now put them all into a single model. That was what was revolutionary about the concepts that got developed between 2015 all the way to 2022. So in that period of about 8 years, computer science went through a complete new revolution because the way that we used to build technology, one piece at a time, and trying to integrate it together, now it's integrated into a single model automatically. So you don't imagine at Google at the time, we cared about more than 40 different languages around the world. If you wanted one language to be translated into another language, for example, English to Japanese or Chinese, and then Japanese to Korean or something like that, each one of them would have been a separate translation model. With this technology, Instead of 40 times 39 models, or nearly 1,600 models, you do it with one model. And you want the document summarized? No problem, same model. So now you understand what I mean by compressing all those capabilities from 1,600 models into a single model. That's what multitask capability and what we mean by Gemini era, partially what we mean by this. What was so incredible about it is that this model not only contains linguistics understanding, but also semantic cultural understanding. So for example, I took 4 years of German in high school. And this phrase I never learned. Ich verstehe nur Bahnhof in German, which means, any German speakers here, by the way? This is a very funny phrase, yeah? Ich verstehe nur Bahnhof literally means I understand only the train station. Bahnhof is a train station. And you probably understand what this phrase means, right? It turns out that if you translate it to I only understand train station, it makes no sense. But it's an idiom, a cultural idiom, right, for explaining that you can't hear anything, basically, you don't understand anything, because the train station is very loud, right? And so if you ask Gemini to explain these things, Gemini actually understands and can explain it. And the explanation, don't forget, is generated token by token, right? So there are a lot of these capabilities that have been built into the Gemini model. And how have we done it? First, starting, as I mentioned, in 2015 or so, with sequence-to-sequence learning. Then the transformer paper came out. And I'm very fortunate to be involved in many of the research since then, including Lambda, which evolved into BAR and Gemini, but also 2 key papers. One was Chain of Thought, which I personally participated in and starting, but also fine-tuning or post-training of these language models, which eventually led to Gemini. The whole point of this slide is to show you that Google was at the forefront of all this research, starting from the very beginning of generative AI. And we're bringing this technology to the user. What we have been realizing is that the entire internet industry is built upon 2 different systems. One is feed, which is a very reactive kind of mode to allowing the user to interact with recommendation systems, and then search on the other hand. And what we want going forward is to enhance users' capabilities in system 1 and system ways of thinking, right? So we're all thinking about reasoning, we're all thinking about intuition. Can we enhance humans' abilities to do this? So yesterday, we actually showed this video that was done by my team at Google DeepMind. So let's roll the video, please. So you'll see our new capabilities in universal agents.
I'm here with the latest research prototype of Project Astra, and we're going to see how it can help me fix my bike. Hey, go online and look for a user's manual for a Huffy mountain bike.
I have found a user manual for you. What would you like to know about it?
Okay, cool. Now scroll until you find the section about the brakes.
Sure thing. Looking for that page now.
I think I stripped this screw. Can you go on YouTube and find a video for how to fix that?
Of course. I'm opening YouTube now. This looks like a good video.
Place a rubber band over the head of the screw.
Oh, nice.
Press down
Thanks.
firmly.
Can you go through my emails with the bike shop and find which size hex nut I need?
Sure. According to the email from Bicycle Habitat, you need a 3/8" hex nut for your sprocket. I've highlighted the correct bin for you.
It seems like I need a spare tension screw. Can you call the nearest bike shop and see what they have in stock?
Yep. Calling them now. I'll get back to you with what they have in stock.
I think my brake pads are wearing down. Can you check the manual again and see if it talks about them anywhere?
According to the manual, if you look on page
Hey.
24,
Do you want to get lunch?
Yeah, give me 5 minutes. Can you finish what you were saying?
as I was saying, if you look on page 24, section 2, you'll see how to replace the brake pads.
Hey, any updates on that call?
Yep, I just got off of the bike shop. They confirmed they have your tension screw in stock. Would you like me to place a pickup order?
Could you show me some examples of dog baskets I can put on my bike?
Sure, I can help you with that. Just give me a moment. Here are some options. I think Zuka would look really great in these.
I hope you all realize how incredible some of the things that we were talking about there was. And Sundar also yesterday showed a prototype version of the Google Glass. And this is actually running a lot of this Project Astra technology in it. In fact, it's the main operating system, essentially, for these glasses. So going forward, what we're working on with Gemini is to add all kinds of action intelligence into the system so that we can bring this technology into the real world. So that Gemini sees what you see, for example, and can take actions, like, for example, call assistants, booking restaurants, shopping, etc. And we're bringing this technology to the consumer as fast as we can. Okay, now let me switch gears a little bit. In thinking about bringing this technology to the real world, the other real world, of course, is robotics. It's not just the universal digital assistant that we're interested in, but we're also interested in bringing this technology into the physical realm, as just the previous keynote speaker mentioned. But what we want to do is able to enable this kind of physical reality where we interact with robots in the physical world in a very seamless way. Now, let me explain what I mean by this. It means that we need to enable robotics and improve on three very important directions. First is generalization. The other is interactivity, and finally, dexterity. So let me explain what that means. Now, what has happened in robotics over the last decade or so is that it has been very difficult to get robots to actually generalize to new scenarios. Even if the background changes, for example, for an industrial robot, oftentimes we have to retrain the entire apparatus to ensure that it actually works well. Bringing Gemini's world understanding capability, what you just showed, in fact, that was connected to the glasses and the Project Astra that you saw, is that its ability to understand the world is unparalleled compared to what we have merely 3 years ago. So what we have been able to show is that the Gemini model enables robotics to be a lot more general across lots of different areas, from visual understanding of what's going on to instruction following, as well as moving forward to real-world scenarios. So let's take a look at a video to show you what I mean by this generalization capability.
Help me get organized. Let's start by putting the pen with the other pencils.
Okay, I will move the pen with the other pencils.
Pick up the basketball and slam dunk it.
Okay, I will pick up the basketball and slam dunk it through the net.
Good job.
My personal favorite was that basketball example, because the basketball is something, that whole setup is something that Gemini has never seen before. And it just understands the natural language and starts doing the task. That's what this new generalization capability means in the future. In interactivity, what we also want is robotics to not be so reliant on a data training loop. It needs to be able to respond and react quickly to new scenarios, to natural language commands, even if you change your mind, and adapt to these different changing conditions very rapidly. So let's take a look at another example of video to show you what I mean here.
Can you put the bananas in the clear container? Can you put the grapes in the clear container? Can you put the grapes in the pink container?
Hey, can you erase the whiteboard for me?
For those of you who have worked on robotics, you'll probably realize how incredible that was, right? It recognizes its mistake, changing the destination or the goal that it was supposed to do, and then replans and executes immediately, all in real time, right? None of that was sped up. Most of the video was all 1x speed, right? So you can see how incredible this technology has become. The other thing is dexterity. Picking up and placing objects that you just saw in the last example, but there's so many other examples of this that were so difficult for robots before. For example, picking up vegetables so that you don't bruise it, or picking up for example, in this slide, looking at how do you tie a shoelace. Now, sometimes when I talk to people, they say, well, Ed, it's great that you and your team are working on all this technology, but all I want is a robot to help me do the dishes, right? And actually fold my clothes, like do the things that I really don't enjoy doing. Why are you making this technology to do the things I enjoy doing, like creativity, like drawing and things like that? Please make something that will actually help me with the mundane tasks that that we really want replaced. So take a look at this video of what we're able to do with Gemini Robotics at this point.
Nice. Now put them in the case.
Okay, I will put them in the case.
How many of you noticed that a human couldn't accomplish the task on that last one? You needed to actually push on the tensioner to make sure that there's enough room for the belt to go on. And then finally, I want to show you one last example of what the advances that we're seeing in Gemini robotics. One of the major difficulties in robotics in the past has been about the fact that every time you change platforms, from one robot arm to another robot arm, from humanoid robotics to other kinds of robotics, you will have to retrain and reconfigure the entire system. And it's a very, very expensive operation. So now we're able to use one model, see the multitask thing that I mentioned before, coming back into play in these situations. We're able to use one model, essentially one system, to adapt to many different embodiments of the physical robot. So take a look at this.
Okay, it's your turn.
What do you see on the table?
I see some colorful letter tiles on the table.
Now, could you spell me something that could be found in a deck of cards?
Okay, how about the word ace? I can slide the tiles to spell it out.
Can you pack me some trail mix?
Certainly, I have packed the trail mix for you.
Hey, can you pack the orange for me?
Of course, I am putting the orange in the lunch bag.
Thank you so much.
All right. So as you can see at this point, perception, planning, reasoning, following natural commands, interactively, all done in real time. It's the first time in history we're starting to see this kind of integration with a single model. And moving forward, what we need from the Gemini research front is agents and reasoning capabilities that will solve multitude of complex problems. We have been hard at work at multi-step complex reasoning, at tool use. You saw the example where it called the bicycle shop to figure out whether the screw is available for a pickup order. We're working on sim-to-real, developing synthetic data generation, and also multimodality input, output, and reasoning capabilities. And finally, a very important part that we're working on also, particularly my team has been really hard at work at this, is personalization. So for example, we want to enable these robots or Astra to carry out command the way that you want it done, right? It knows about your dress style, for example, clothing style, and suggests the right products for you to consider. This kind of personalization and preference alignment is a very important part of our research direction going forward. As Sundar said, I'm very excited about the next chapter of this kind of embodiment of AI, whether it's in a universal assistant or in robotics. It's really inspiring to think that the research that my team and myself were doing only a few years ago, now becoming available widely. And it's helping robots finding treatment for diseases. We're even working on quantum computers and obviously delivering full self-driving autonomous vehicles also to lots of parts of the Bay Area at this point. So if you ever come to Mountain View, please call me up and we'll go on a ride in a Waymo car, which is really pretty amazing experience. So thank you very much for your attention, and we'll have the next talk coming up. Thank you very much.
Thank you, Mr. Chi, for the fascinating presentation. Up next, we have Mr. Giovanni Campanella, Vice President of AI and Machine Learning at Texas Instruments. He will provide an overview of how to build future humanoid robots with semiconductors. Welcome, Mr. Campanella.
Hello, good morning. Good morning, everybody. How is the energy level? Good. So I'm really excited and honored to be today and this year at COMPUTEX among so many innovators like you that are really shaping the future of the technology, the future of robotics, and the future of the world. You know, if you look at my title of the presentation, you might think I'm going to talk about, things that are going to happen 3-5 years from now, right? But the truth is, the reality is, humanoid is the present. We are already seeing, and had Deepu already show some examples in the videos, we are already seeing humanoids, prototype of humanoids that are walking, that are working side by side with humans, that are performing complex tasks like the one we just saw from the video from Ed. And it's incredible where we are today in this journey. But what has changed? Have you asked yourself, what has changed at the past 1 or 2 years? What has changed in this industry? And technology like AI that's been discussed or will be discussed a lot at COMPUTEX, motor control, sensing, communication, all of this technology have reached a very good level of maturity, which are setting the foundation for hardware and software that allows to go from prototypes robots to production-ready robots. I was just a few weeks ago at the Robotics Summit in Boston, and I was walking, I was going to a conference, and I turned on my right side, and I saw a Unit 3 robot walking side by side with me. I was like, wow. And I wasn't surprised. I was actually excited to see that, because finally I saw that all the work that we have put in this market over the past decades, my team, you, all the people that work in this space are finally giving the results. And this is not only about the last decades. This really goes back in time. And the first robot, how many of you knows when the first robot actually was invented? The first robot was invented and released to the market in the 1960s. Imagine, very long time ago. And this robot was performing very simple task. It was, taking a hot metal plate from one place, and he was putting in an automotive production line. And from that time onward, robots is performing more complex tasks, more difficult tasks, going, for example, from those industrial robots that just execute to collaborative robots that now respond to the environment where they are placed into. And they act and work and cooperate side by side with humans in a safe way. And if you now to add to those robots the wheels, it becomes even more complex, because now this robot is not anymore in a semiconductor lab bench, but is now going around your warehouse. And now the complexity is even more, right? Because it's now the robots need to navigate through the warehouse, create complex paths to move, boxes or pallets from one place to another. And the complexity becomes even and even higher. And now you move from a warehouse environment to your homes. And guess what? Now you are moving to a non-structured environment, and where things change from a minute or from a second to a second. For example, you spill a cup of coffee on your floor, or for example, you have a pet, a dog that wants to play with your robot, or your kid that wants to play with the robot, right? And the robot needs to adapt to that environment. A humanoid is really all of these robots into one. Humanoids need to perform all these tasks. They need to walk in very different terrains. They need to pick, as we have seen in the video, different type of objects. They need to understand what objects they are picking, and they need to do that in a safe and secure way. But how we are making sure that all of this happen? And that's only possible by innovating in areas like motor control, computing, sensing, communications, and of course, safety, AI. We've been talking about AI. AI that is fueling every of those areas like motor control, computing, sensing, communication. And only by innovating in those areas, creating a more precise motor control, designing a powerful computing engine, and designing a very precise sensing subsystems, and then making sure you have a real-time communication with a foundation layer of safety and AI. Only by innovating in all these areas is possible to build smarter and safer robots. And, you know, have you ever asked yourself how many motors do you think are in a humanoid robot? 10? 20? 30? More than that. You have over 40 actuators in a humanoid robot. Imagine, I mean, look at yourself. You know, look how many joints, right, you have, right? You have the knees, you have the wrist, elbows, shoulders. Imagine how many motors you have in a hand. It's impressive, right? You need a lot of actuators to make sure those humanoids moves similar like us. And beyond the actuators, you need to have sensors. You need to have sensors that perceive the environments around the robot. You have, like, for example, radar. You have cameras. You have LiDAR that, you know, detect, classify obstacles, recognize obstacles around the robot, and make sure, you know, the robot is able, you know, either slow down or change direction, and so on. And you have other type of sensors that maybe we don't talk much about, but they're super important, like torque sensors, right? Force sensors that, you know, detect if an external force is applied to the robot. You have touch sensors. We saw the example before of the game where the robot was picking a very small piece, and you need tactile sensors so that the robot can detect what I'm actually picking. I'm picking like a fruit, I'm picking like a dice, or what I'm picking, and adapt very quickly to whatever is picking. And all of this is put together. You need to have a computer. You need to have the brain of the robots that, you know, take all these sensor data, analyze those data, compute those data, and make sure we take, or the robots take, a decision in a very quick way. And all of that, all of those pieces are connected with a communication system, with interface that needs to be real-time. Today we see mainly the communication interface being CAN, but we see moving towards EtherCAT and SPE, single-pair Ethernet, which at the end of the day reduce the number of wires in the robots or the cabling and making the robot less weight, and so also more performant and efficient. But let's dive into each of those areas, right, that I've been talking about. And let me tell you, where is innovation? What are we doing at TI to power the humanoids robots? Starting with AGI, which is a topic, you know, been discussed now extensively over the past few years, you know, especially this year, the GTC conference at CES, of course, now at COMPUTEX. AGI, I will start with an example. imagine here that the humanoid is walking, right? And suddenly, somebody jump in front of the robots. You need to be able to take a very quick decision. And that decision, that quick decision, can only be possible if you use Edge AI. Because Edge AI reduces the latency of your system and so allows the robot to, either turn or interact with that person if that person wants to interact with the robot, or slow down if that person just moving out of the way. So that's only possible with Edge AI. And it's very important, Edge AI doesn't come for free. That's power. Computing is power. Sometimes we forget. We forget, that computing is power. And one of the biggest challenges of those robots is that the battery life today doesn't last that long. And that's where innovation comes to the game, right? We need to have Edge AI, but we need to have efficient, power-efficient Edge AI to make sure that that battery life lasts as long as possible and the robot's operation can operate as long as possible. Either this will be in your warehouse or in the industry or at your home. And it's very important that that compute engine that you're taking is safe, or has safety features built in that allows basically engineers that are designing those systems to create humanoids that at the end of the day can work side by side with humans. And moving to the now real-time control, we are investing heavily in real-time control. And again, I would like to bring up an examples where it's very important, for example, that your joint, for example, your knee joint or the humanoid's knee joints is very accurate and precise, because you want to make sure that the robots doesn't lose the balance. It doesn't make sure that the robot doesn't fall. And so it's really important that you have a real-time and accurate motor control. And also, you want to make sure if the robots, for example, is grabbing a dice or is grabbing a apple, you want to make sure that that sensor feedback is feedback to the MCU, to the control piece in a real time, so that the motor control adapts and is able to pick any type of objects. And again, here, the real-time control is enhanced by AI, again, by hardware accelerators that help to have that real-time accuracy and precision. And also, AI hardware accelerator help to monitor if there is any failure in the motors. And moving to the next piece, to the power stage piece. So motor control MCU goes hand in hand to the power piece, right? You need to have a drivers that at the end of the day, takes care of driving those motors, right? And here again, think about it. Unless you want to create a giant humanoid, your actuators needs to be in a very small form factor. You are in a very space-constrained environment, right? You are in a space-constrained systems. So you need to design actuators that are really small. And you know what? Those actuators actually handle a lot of power. I mean, we are talking here about 1 kilowatt, even above 1 kilowatt, for example, for joints that carry a lot of weights. And how are you going to dissipate all of that power in such a small form factor? This is where wide bandgap technology comes to the game. So a solution like GaN allows you to create a very small form factor actuators that is efficient, that is small, is quieter, and is cooler. Let's move to the communication piece. As I said earlier, right, all of these pieces, I've been talking about the compute engine, I've been talking about the real-time control MCU, I've been talking about the power stage, but it's important that all of these pieces communicate together, they're linked together, and they're linked together via the communications, via the interfaces. And that's really important. Again, imagine a humanoid that is interacting with a human, and he needs to hand over something to the human, right? And you will have a vision system that will detect where is the human place, what is he doing, the motion, and that vision system needs to communicate real time to the compute system all of this information so that the compute system can communicate with the actuators in order to hand over that object that the human wants. So communication is very important and needs to happen real time. Another example that I like to make is the robot is moving and the terrain change, and so it's very important that the sensor at the feet of the robots communicate that change again to the compute unit and adapt the actuators that is on the knee or on the feet in order to be able to walk in the new terrain. Communication is very important, and so you need to have real-time control MCU or real-time MCU that handle those industrial protocols. You need to have very low latency PHYs that allows you to achieve all what I've said. And moving to the perception piece. So all of this is only possible if the robot is seeing the environment around it, right? All of what I've said it will not be possible if the robot doesn't have any sensors. So sensors are very important to detect the environment around the robot. So, and sensors like radar allows the robot to have a 360-degree view, looking everywhere, what is coming from behind, from the sides, allows to detect the speed of the target, where the target is coming from, which direction, where is the target, and that's possible only with sensors like radar that allows or enable perception sensing for the humanoids. And again, even here, safety is a key piece. Having those sensors that have safety features integrated so that the robots can again work safely side by side with humans is super important. And you have been hearing me talking a lot about safety, right, over the past 20 minutes. And I want to say that safety is not a requirement anymore. Safety is the foundation of every design, of every robot design. Safety is the foundation of every robot. It's extremely important that those robots act safely. I've mentioned examples of the computer engine that needs to have safety features integrated. I've mentioned example of the real-time control MCU, so the actuators needs to have built-in safety to make sure it reacts to any malfunction. I mentioned the radar piece, right? It's important. We see robots creating a safety bubble, a safety area around it in order, again, to slow down, stop, or turn, depending, where, if the objects or if the humans want to interact, or, it's just passing by. So safety is very important. Why is safety important? Because it's important when you have a sensor glitch or you have your motors that is failing. It's very important that you just don't stop the robot, and the robot is gonna fail, or maybe hurt somebody, right? It's important that you detect the failure, understand that failure, and then it's very important that you stop safely. It's important your robot stops safely. And so, just to not say that I'm not just talking and showing a slide here. Actually, we have partnered with Aptronic on a humanoid robot. So Aptronic actually develops Apollo, which we show it also at CES this year. It was a Texas Instruments booth, interacting with humans. And the reason why Aptronic, picked TI as a partner is because of how serious we are about safety. It's not only about, I've been talking now about semiconductors and how you can integrate safety features in semiconductor. It's not only about that. It's not about that, but it's also about our understanding of safety, especially, the team that I lead, we have system safety expertise that we focus on the system. We're understanding these type of systems that I've mentioned, as I mentioned now, they're very complex systems. And we help customers, Aptronic, but also beyond Aptronics, robotic customer, to achieve those safety levels that are required by the industry. And most importantly, not only that because they are required by the industry, but because we want that those robots, at the end of the day, they work side by side with us in a safe way. And with this, I'm really excited. I'm really grateful, that worked you through this journey, right, from the evolution of robotics, from industrial to Aptronic to humanoids. Of course, Aptronic being one of the examples. And I'm really proud, of being part of this journey with the technologies that, are fueling this industry, like motor control, communication, safety, AI. It's really exciting to be in this journey. Either you are a supplier, semiconductor supplier, or mechanical part supplier, or whatever supplier, or you're building the humanoids. It's really exciting because this is one of the industry where breakthroughs are happening, where innovation is happening. And I'm really proud to be part of TI as we are enabling those innovations, and I'm looking forward to partner with all of you. Thank you.
Thank you, Mr. Campanella, for demonstrating the power of semiconductors in the future of humanoid robots. President of the Embedded Sector at Advantech, who will speak on edge AI-powered autonomous systems and robotics. Let's give a warm welcome to Mr. Miller Chang.
Hello, everyone. Wow. Good afternoon, ladies and gentlemen, industry leaders, and media friends. I'm Miller Zhang from Advantech. It is great to see you here in COMPUTEX Forum. In this session, we will dive into a hot topic, edge AI and robotics. There used to be two separate things. One is AI at the edge, and the other is the robotic industry for emerging application. But once they come together, robots get smarter, faster, and create more business value to our industry. So let's get started to see how edge AI can power robotics industry. So before I begin my presentation, let me ask everyone you a question. Has anyone designed a robot? Please raise your hand. Oh, not many people. Or has anyone used a robot? Okay, I see many people, okay. Oh, please look at the big screen. Has anyone seen a robot in daily life? Please. Good, fantastic. You know, if you can say no for my three questions, then why are you here today? I hope the briefing later will give you the whole picture, clear idea, how edge AI can empower the robotic industry. Let's get started. First, I want to share with you the evolution from the edge computing to edge AI. Many years ago, device as an edge. Each device works alone, one task, one location, simple and focused. Then about 10 years ago, as the rest of the IoT, edge to cloud connected. Each edge device is collecting the data, sent to cloud for data processing, and waiting for decision. And more importantly, at that time, the intelligence are most living in the cloud. And recent year, because of the AI technology gradually mature, edge devices become AI with powerful AI technology has become introduced into edge devices. Edge devices become a smart system. They are able to learn, adapt, respond in real time. So AI and IoT come together, they create a huge business for our industry. I want to share with you some business case, the real example. This is just a few real examples you can see from the robotics, healthcare, manufacturing, and smart cities. I give you some highlight. You see the robotics, humanoid robot and AMR working in the warehouse and logistics, saving the labor cost and enhance the production capability and efficiency. You also can see the industrial drone start to service in the smart agriculture. You see the medical, the traditional medical imaging processing with AI technology, like enhance hundreds, even thousands times of efficiency. And also recently, you see the hospital, more AI surgical robot in hospital. Smart city, from a self-checkout system in retail to the public safety, to airport security screening, to the traffic monitoring system. So Edge AI has been introduced into many different industries. This is not just the future. Edge AI is happening right now. Let's zoom in to the robot market today to see how Edge AI can really drive the emerging market opportunity in robotics. Okay. You see, there are many different robotic applications, right? Start from 30 years ago, maybe more than 30 years ago, the robot arm are using in the automation industry. The purpose is very simple: reduce the labor cost, enhance the production capability. And we move to the automated guide vehicle, AGV, autonomous mobile robot, AMR, and now service robot. You may have to see many service robots in retail market, retail store, and restaurant, right? Then also industrial drone for smart agriculture, as I mentioned earlier, and also the humanoid robot are entering the real world scenario. So this is a super big opportunity to all in our industry. Let's take a look about the global robotic market research. We are entering a very high growth rate era. The global robotic market growth rate will achieve projected 16% compound annual growth rate. The strongest growth momentum market are the collaborative robot and humanoid robot. You see, there's a very big number, around 30% CAGR. Quite impressive growth rate, right? But at the same time, today, AMR, robot arm, and service robot contribute a biggest share of the market size. They are best solution for the logistic, warehouse, and service industry. So we are at a time of the rapid growth for the robotic industry. So how can we do? How we can support our customer, our partner to catch up the chain for robotic industry? At Advantech, we are design a core architecture, a set of the essential building blocks to accelerate the robotic industry application development. Start from the Edge AI. The core building block is Edge AI. It's a brand of the autonomous system. There are some functions supported, right? Like speech recognition, language model, digital twin, right? AI inference deployment, try to connect the real-time sensing to decision-making at the edge. And also, the autonomous system need to integrate the sensor and control module. So you see, from the vision sensor, like 2D, 3D camera, to communication module, like Wi-Fi, Bluetooth, 5G networking, to navigation system like LiDAR, IMU, and all the way to the machine control, right? And last one is the system integration, also the key for autonomous system. So how to connect the sensor, decision, and execution modules seamlessly connect together to provide a truly autonomous system working in complex and dynamic environment. So this is the reason that we provide the robotic building block to our customer and partner. Let me give you some detail about the building block. That is the Advantech Edge AI platform. You see, there are different layers of the computing, Edge AI computing, from the Edge AI embedded module, Edge AI appliance for the application, and also Edge AI server. Okay. Again, as I said earlier, the Edge AI is a core function core building block is a brand of the robotics, autonomous robotics. We co-work with the mainstream silicon vendor to come out the diverse range of the Edge AI platform. For example, the GPU and NPU acceleration module, they can plug in to edge computing, upgrade your AI computing power instantly. Also, the newly CPU with NPU integrated, only upgrade the AI CPU. You don't need to change any system architecture. Okay. But we are not just provide the Edge AI hardware platform, but also building the software toolkit, software stack to support our customer, our partner, to speed up your robot application development. Robot Suite is a toolkit to support our Edge AI, to support our partner, your vertical application, especially on robot, your product development face to the market. There are three key messages here. The first, the multiple support silicon, many different silicon that we can support it. From NVIDIA, from Qualcomm, from Intel. Their AI SDK and also robot SDK has been integrated into one package. Second, is a graphical user interface that our developer, our partner, can very easy to leverage the pre-integrated sensor module and software module. Last but not least, the seamless integration, as I mentioned, like sensor module from the video, camera, 2D and 3D camera, to wireless module, to motion control, the system integration altogether. Okay, this is an all-in-one software package. Most importantly, the Robotics Suite has fully built into Advantech Edge AI platform. The only one purpose to support our customer, the developer, your robot application face to the market. Okay, so today's topic is Edge AI and robotics. So let me pause here to give you a quick summary. Four key strategies. First one, we will continue to innovate the edge computing with AI technology. AI on the edge will becoming a new standard. Second, we'll provide a wide range of the module, like the robot, to support robot, to give them the eyes, the ears, and connectivity for a human-like precision. Third one, Robotics Suite can support our customer again. Your robot application face development to the market. And all above the design support services will have the ISO standard and compliance. So that's our four key strategy to support our customer and our partner. All right, so I want to give you some real business case. You see there some big logo there, right? They are all real business. I want to share with you some of them. The first, TechMan. We are collaborate with the TechMan to design the AI collaborative robot. They call AI Cobra. It combines the native AI engine, robot arm, and also vision system together. You see the video, very precise and powerful AI collaborative robot. TechMan, great company, great partnership. Second, we see Sony, right? You know, they do have the very excellent AI algorithm with the CMOS camera put together, like an enhanced 5 times of optical evidence ability than traditional AMR. So their autonomous mobile solution and robot Advantech Japan team working with them. Great job, Sony. Also, you see the Kepler humanoid robot from China, and also the NEC, they do have the collaborative porter robot. Okay. They are all real business case and already in action. Okay. So I want to show you one more example. This is really in action, outdoor, the full autonomous. It is a petrol robot. Okay. And then we co-work with the freight company, put everything together, all the building blocks together to come out the petrol robot. So you may be thinking that this is just a video or computer graphic, right? So seeing is believing. Let's welcome my special buddy. This is the B-boy, huh? How about little guy? This is what we collaborate with the Play robot and also Unit 3 to come out the amazing petrol robot in action. I know some of you want to take the photo. Don't worry, I will give you time. All right? How about you, little guy? Okay. Let me show big guy first. You want to take a photo? Come closer. Come closer. All right, all right. I give you 3 seconds. Good? Everyone got a shot? Okay? Okay, let's move on. Let's move on. If you're ready, you can come, okay? Little boy. Come closer to me. So, big boy, what are you bringing to me? What are you bringing to me today? You don't want to give it, huh? All right, all right, all right. Take it. I take it. It is an autonomous mobile robot development kit. Okay. Yeah, I know it's quite popular, but let me introduce that later. How about the big boy? Say hi to everyone.
Hi, everyone. Great to see you here.
Okay, little boy is still nervous, so wait a moment, okay? Come to me, all right? So, you know, you may be thinking how we can develop the petrol robot, something like this. It's because we provide the dev kit for your reference. They will have a full set of the package. I give you some idea. First, real-time edge AI module inside. Okay. Second, we integrated the camera module and sensor module. Very important, as I said earlier, the petrol robot need to have the eyes and ear. And also connectivity for wireless, reliable wireless connectivity. And more important is the software solution. Software solution. Edge AI and also our software robotics suite can be up together as our development kit. Okay. So with the dev kit, our customer and partner, you can build the robot like AMR or service robot or the petrol robot like my special body. Okay. Then, how about next? How about next? Big boy, help me to bring this. Okay. Oh, it moved very slow. Yes, yes. Good, good, good boy. Oh, you come. Okay, welcome my little boy. Come closer. You come closer. 过来一点，过来一点。He can learn Mandarin. Come closer. All right, all right. Oh, okay, okay, okay. And then you need to take another photo. Okay, 3 seconds. Good. Everyone okay? All right. All right, then your turn. Little boy, say hi to everyone. You are late. Say hi to everyone. Okay. How cute, huh? Okay. Okay, don't be excited. Could you please move to my left? To my left, 去左边. Then I can better talk to you two at the same time. Come closer. Yes, yes. Please sit. Please sit. I know there's no chair there. Please sit. Okay. That's my special body. I'm sorry, he's so nervous, so that's the reason he coming late. I hope not interrupt your time too much, all right? And then, well, I already talked that already, and the last topic is about the ecosystem. To involve the Edge AI into the industry, we need ecosystem and partnership. From silicon partner to sensor provider to wireless designer and software developer, industrial alliance, and also ecosystem player, everyone played a role. That's exactly what Advantech we are building here. That we would like to invite everyone to co-create the new Edge AI and robotic market together. I think it's a good time to wrap up here. In today's session, we are talking about the Edge AI and also robotic market. I share with you our core architecture and our building blocks to support the robot application. I also show you some real cases by video and by my special body here. So I would like to invite you to take a look for a short video. It brings everything together that we are, Advantech, want to commit it to shape the future with all you together for our industry. Let's take a video.
All of this drives smarter cities, more efficient automation, and more sustainable energy. Enabling industries to create greater value with fewer resources. Edge computing and AI have the power to transform major industries, including manufacturing, energy, services, and healthcare. By building comprehensive ecosystems and delivering agile services globally, Advantech is driving future Edge AI innovations. At Advantech, every second matters. Every decision, every connection, and data point collectively shapes the future of technology. With the ongoing development of edge computing and AI, Advantech continues to unlock greater possibilities that enable a more intelligent planet. As pioneers of industrial intelligence and edge computing, Advantech is helping to build a smarter future today.
Thank you, everyone. I enjoy your day at COMPUTEX. Thank you. 谢谢大家. Let's go, buddy. This way. This way. Thank you.
Thank you, Mr. Chan, for your insights on the power of Edge AI. We've had a stimulating morning filled with insightful presentations, but the conversation doesn't stop here. Join us for the afternoon sessions as we explore what's next for generative AI.